Today's video, we're going to focus on solving quadratic equations by factoring. Before we start solving anything, I need to review with you how to actually factor. So there are several different types of factoring, and I've highlighted some of the questions on the first 17 problems on your packet. So I want you to get a pen, pencil, highlighter, something like that, and I want you to highlight, circle, underline the questions that I have on my screen, so that way you can try to do these on your own. So I want you to highlight questions 1, 4, 5, 7, 9, 11, and 14. All of these questions, I want you to take about 5 minutes and try to solve each of them. Don't just sit there and say, oh, I'll wait for Ms. Tapia to do it in a second. This is Algebra 2. You should know how to solve each of these problems coming into my class. If you don't know how to solve any of these questions, we're going to have a big problem with solving future problems about factoring. So right now, take the time to ask somebody next to you if you need to, work by yourself, but try to figure out what each of the answers are. Once the 5 minutes is up, unpause the video, and I'm going to show you each of the answers, and I'll work through each question. Okay, so you guys are all young adults, so you should have been able to pause the video, try each of the questions, but I posted the answers here. So I'm going to show all of the answers first, and then I will go through each and solve. If you got all of these questions correct, awesome. You can actually skip ahead in the video to the next part, which is actually us factoring and solving the quadratic equations that follow. So let me show you all of the answers. In the first two, we have the following answers: 3x times x plus 2, and then negative 1 times 6x squared minus 15x minus 11. We have the next section here, x plus 3, x minus 3 for the question 5. Question 7 is 5x plus 7y, 5x minus 7y. And then for number 9, that one is not factorable, so you cannot factor that no matter how hard you try. For question 11, that is going to be x plus 12 and x plus 3. Put an equal sign behind that. And then question 14 is 3x minus 1 and 2x minus 1. If you got all of those questions correctly and you understand what to do and you're good and you're ready to move on, cool. Skip ahead in the video and you can go ahead and solve the remaining questions. If you even missed one of these questions, guys, wait until I go through the problem before you try to skip ahead. You're not going to hurt anybody but yourself by skipping ahead and not learning from the mistakes or the content that you don't know from Algebra 1. So for question number 1, the first thing you need to do is figure out what is your greatest common factor. So the greatest common factor is the biggest number that both terms have in common. Well, in both of these, I have a 3 and I have a 6. So we need to think, what is the biggest number we can factor out between both of them? Well, the biggest number we could do is 1 because they both have multiples of 1 times 3, for instance, and 1 times 6, if I could write that correctly, 1 times 6. But another multiple for 6 is 2 times 3. Keeping in mind this 3, that's actually bigger than 1. So we're going to actually take out a 3 from both of these terms. So from the 3x and the 6x, we're going to factor out a 3. Notice that both of these terms have an x in common. Let's try that again. They have an x in common. This one has 2 x's. This one has 1. So both of these terms at least have one x in common that you can factor out. All we need to do now is put whatever is left over in this parentheses. So in this parentheses, the items that are left over are x, because 3x times x will give you 3x squared. And then we'll add 2 to that, because 3x times 2 is going to give you 6x. So the great thing about factoring by GCF is whenever you find your answer, all you have to do is distribute. If you distribute, you should get the exact same item you started out with, the exact same expression. All right, let's look at example 4. In example 4, the first thing you want to look at is each of the questions, or each of the terms in this expression. Okay, well, I have a 6, a 15, and an 11. My first thought is with 6 and 15, I can actually divide both of these by 3 because of the multiples 2 times 3 and 5 times 3. Both of those have a 3 in common. So right off the bat, I'm hoping I can factor out a 3 from both of these terms. However, 11 is prime. Prime means that 11 is only divisible by 1 in itself. So unfortunately, remember that good idea I had about factoring out a 3 from each term? Since this 11 doesn't have a multiple of 3, so it's not like 3 times something to give me 11, I can't use 3. And don't say, oh, Miss Tapia, we can use a fraction. No, no, no. We don't need to use fractions. We just use whole numbers when we're finding multiples. So for this question, the only thing we could factor out usually is a positive 1. But since this leading coefficient, the negative 6 in front of x squared, has a negative sign in front of it, we're going to factor out, as it says in the directions, a negative 1. So if your first term is negative, factor out a negative 1. So that's why we factored out a negative 1 first. Let me rewrite this in green. And that's going to leave in parentheses everything that's left. Some students say, oh, Miss Tapia, you could factor out an x. Does this 11 have an x with it? If it did, then you'd be absolutely right. We could factor out an x. But since we don't have an x with the 11, we're going to make this 6x squared, because negative 1 times 6 will give me negative 6. Minus 15x, again, because negative 1 times negative 15 is positive 15. And negative 11, because negative 1 times negative 11 is going to give you positive 11. So that's how I got each of those answers in red. If this was something that you struggled with, good. Make sure you try questions 2 and 3. Put a little star next to this section so you can do questions 2 and 3 at a later time. I have all of the answers for this, so if you need the answer key, just let me know. Difference of squares. Okay, difference of squares, there's a few ways that you can do this. Some teachers just have you memorize a formula. I have you try to think while you memorize the formula, but let me kind of show you what I mean by looking at example 5. So in example 5, difference of squares means that you can actually factor it without doing that huge X chart that I've been doing for days. So usually your teacher had some kind of method that they did. You don't need to use that method. We're going to talk about difference of squares more later on in the semester, probably next semester. But I want to show you guys at least what this means, because this is an Algebra 1 concept. So when you have a difference of squares, you have two terms. There's no x term in the middle. So I'm going to make that little note. There is no bx term in the middle. And what you can do is technically square root the a and the b. So when you square root a squared, that's just going to simplify to a, which is this guy and this guy. And you can square root the b squared. When you square root the b squared, that's going to give you this guy and this guy. Whoop, went too far over. And this guy. So for instance, for question number 5, if you're looking at that problem that I just wrote, it says that if you take the square root of each of these terms, you'll be able to get your answer. So we're going to take the square root of x squared. Okay, well, x squared is just going to simplify, because literally when you do this, the squared and the square root are going to cancel. So you're just going to be left with x. So in that first place, I put an x here and I put an x here. The next thing we're going to square root is the 9. Not negative 9, we're just going to square root the 9. Well, the square root of 9 is just 3. So that's why I'm putting the 3 here and the 3 here. What makes this a difference of squares is you're going to have one positive symbol and one negative symbol, just like you have here. If you were to FOIL this out, you would get the exact same answer that I have here. If you don't believe me, take the time now and FOIL this out. You're going to get the exact same answer here. So that's all you have to do. When you're finding your difference of squares, just do this step, take the square root of each term, and then put it into its two binomials. It's going to be the exact same binomial. The only difference is one will be positive and the other will be negative. Let's look at example 7. Example 7 is a very good kind of view as to what I was just talking about. So we're going to take the square root of 25x squared. Okay, well, the square root of 25 is 5. And we saw this before. The square root of x squared is just x. So notice that the 5x is going to be here and here. Now I need to take the square root of the negative 49y squared. Remember, don't include the negative, just put the positive 49 and then the y squared. Well, the square root of 49 is just going to give me 7. And the square root of y squared, the same thing's going to happen like we did here with x. The square root of y squared is just going to be y. So that's how I got this term and this term. All I did from there is I just made one binomial positive, the other binomial having a negative. That's all. There's a little bit of a difference between questions 5 and 9. If you look at questions 5 and 9, number 5 is a difference of squares, And number 9 is what some students will call a sum of squares. Well, I'll tell you right now, guys, sum of squares does not exist. It's not a mathematical concept, at least not one that I'm going to be teaching you in Algebra 2. So if you see something that looks like this, be careful. Since the problem here is not a difference of squares, I'm going to make a note. This is not a difference of squares. If it's not a difference of squares, sure, you could take the square root of x squared and you can take the square root of 9. But if you were to try to write 2 binomials like we did for number 5 and check it, you would never get this answer. Never. So what you're going to write instead of an answer is just not factorable. You literally cannot factor this. Let me scroll this over so I can actually box this. But you cannot factor this. It's not possible. Let's look at question number 11. For question number 11, this one I need to use my little X chart. So I've been doing that, I think, since probably like the first couple days of school. But I usually will label my A, B, and C value, and then I'll make my little X chart. Okay, so for my A value, that's the coefficient in front of x squared, so that's going to be a positive 1. B is the coefficient in front of x, which is 15, and C is the constant, that's 36. So I need to find, in this little X chart, I need to find 2 numbers that multiply to the product of A times C, which is just 36, but add up to B. So the B value goes down here. So I need to find 2 numbers that exist, whole numbers, not fractions, that will multiply to 36 but add up to 15. For some students, they don't have a very nice time with trying to figure this out, so I just literally tell them, write all the multiples for 36. They look at me crazy, but trust me, it'll help you. So we're going to do 1 times 36. I can also do 3 times 12, and I can do 6 times 6, just to start it off. If you don't know what to do, at least write a couple to start it off. Okay, from here, I always tell my students, okay, after you have a couple, start adding, see what happens. All of these multiply to 36, which is what I wanted. That's great. Now I need to see if the same combination of numbers will add up to 15. So when I do that, I'm going to add. That'll give me 37. Can't be those two. I'm going to add these two. That'll be 15. Ooh, this looks nice. And then if I add 6 plus 6, that's 12. Can't use that. So the only 2 numbers that will multiply to 36 and add to 15 is 3 and 12. Here's my next favorite part, specifically for this section. Since the problem asks you to factor like normal, all you need to do is make sure that your leading coefficient is positive 1. Since your leading coefficient is a positive 1, I'm just going to write my answer just like this. X plus 3 and x plus 12. Notice, these two are the exact same. I've just literally put the x plus 12 binomial first here and the x plus 3 binomial second here. When you multiply them and do the product, you're going to get the exact same trinomial that I have here. One thing that I probably should have done first was check the entire problem for a GCF, but I got ahead of myself and I realized that there really isn't a GCF besides one, so I'll make sure to check it for sure on the next question. This method that I use, I will not take off points if you use a different method from a different teacher. However, if you get the question wrong by solving it incorrectly, I'm going to start making you use my method because my method causes students to have significantly less issues with solving. All right, last question I'm going to look at before we actually complete the content is question 14. So with question 14, it says if there are 3 terms and the number in front is greater than 1, you have to factor by grouping. So I'm reading the little directions at the top up here. So we're going to have to factor this by grouping. Okay, first things first, check for a GCF. Is there a number or variable that you can factor out from all 3 terms? Unfortunately or fortunately, however you want to look at it, for this question, there's nothing we can factor out besides a positive 1. If you could factor out a positive 1, that's cool, but it's not going to change your answer. So A is going to be 6, B is negative 5, and C is 1. I'm going to make my little X chart, and I'm going to multiply A times C, which is 6, and I'm going to recopy my B number down here. So what this tells me is I need to find 2 numbers that when you multiply will give you a positive 6, and when you add them will give you a negative 5. So again, if you don't know what to do, just write out the multiples. And after you have the multiples, just think about it. I need these numbers to multiply to 6, but add up to -5. Well, since I see this -5, let me make all of these numbers negative because -1 times -6 is +6. -3 times -2 is going to, again, be a +6. So when you change your numbers, guys, make sure that you put the correct sign. All right, from here, I'm going to go ahead and add. So this will give me -7. That can't work. And this one will give me -5. These two are what I'm looking for. All right, what I need to do now is it said at the very end, let me move this over and highlight this. It specifically told you to factor by grouping. Factor by grouping is my go-to method, and it'll probably be your go-to method for every other class you have on our campus. So to make your life easier, let's use factoring by grouping. The A value is not a +1. I don't care about the B and C. This A value is not a +1. Since it's not, we're going to factor by grouping, by rewriting the entire expression, but we're going to plug in -3 and -2 for the 5x term. So we're going to make this 6x squared minus 3x minus 2x plus 1. I tell my students all the time, if you put this as -2 and this as -3, I'm not going to take off points. Just make sure that you write one of the terms as -3, the other one as -2, at least for this question. Remember how I said we were going to factor by grouping? We're going to group the first two terms and the last two terms. In both groups, we're going to factor out the GCF. So ignoring this one here, what's the GCF between both of these terms? Well, in both of these terms, I can factor out a 3 from each of them, and I can also factor out at least one x. So we're going to factor out a 3x from both of these terms. That's going to leave in parentheses. 3 times 2 will give me 6. X times x will give me x squared. So I'm doing 3 times 2 will give me 6. X times x will give me x squared. And then in my next term, 3x times, well, let me see it. Well, I have a negative there. Let's make that -1. 3 times -1 is -3. And then this x times really nothing is just going to give me that x. So if I was to distribute this, I would get the exact same thing as here. Ignoring the first part that I just did, let's factor out the GCF from here. Well, if you're factoring the GCF from here, we're going to first factor a -1. And the reason why I'm factoring a -1 is because this sign here is negative. Just a good play hint that you have whenever you're solving these. If this term is negative, always factor out a negative. Even if it's a -2, a -3, a -4, if it's negative, factor out that negative first. You'll thank me later. That's going to leave in parentheses. And remember, guys, there's no x here, so there's no variable that I need to factor out. This is going to leave me with 2x because -1 times 2x is -2x. And I know I need a 1, but what sign? Negative times what will give me a positive? Negative times a negative will give me positive. When factoring by grouping, the first and immediate thing you want to check, are both of these binomials the same? Since they are, with factoring by grouping, that's going to be one of your solutions or one of your binomials for your answer. The other binomial is going to come from the GCF that you factored from each. So I'm going to rewrite my GCF as 3x minus 1. This is your answer. Or this guy up here. They're both the same thing. So we've refreshed your memory on how to factor. So let's go ahead and do the questions below to see if you can do this by yourself. So again, for the questions below, for the solving by factoring, I want you to pause the video and take about 5 minutes. Try to solve questions. Let me get my highlighter. Try to solve questions 1, next page, 2, 3, and I would love to do all of these. I guess we'll do 4. So questions 1, 2, 3, and 4. So go ahead and pause the video, and when you're done, go ahead and unpause it. All right, let's see what kind of questions we have. So I like to give you guys some steps anytime you're solving anything or having a process that you need to remember. So first thing I want you to do for all of the questions is set each equation equal to 0. Once you do that, factor completely. Factoring completely is a reminder to check for a GCF. So check for a GCF. Make sure you do that. Let me actually erase that F, rewrite it. There you go. That looks like an F. And then once you check for the GCF, if you have one, of course, factor it out. And if you don't have to factor it, then fine, continue to solve. You're going to set the factors equal to 0 once you do factor it completely, and then you're going to solve. So let's start out with question number 1. With question number 1, the first thing we need to do is make this equation equal to 0. So that means I'm going to have to subtract x on each side. And then I'll have to subtract 30 on each side. What I need to do now is factor. So based on the discussion we just had on the last page, question 11, let's go ahead and factor this. So my a value is 1, b is -1, and c is -30. I always see this happen, guys, where students don't make the equation equal to 0. If you don't set it equal to 0, you will get the question wrong. We're going to multiply a times c, which is -30. And your b value, we're going to recopy down here. I need two numbers that multiply to -30, but add up to -1. Well, the only two numbers that can do that are -6 and 5. Those are the two numbers. So we're going to take both of these and we're going to look at the a value. If you look at this a value, does this mean we have to factor by grouping, or can we just write both binomials? Well, since the a value is 1, we can just write both binomials. So we're going to take x minus 6 and x plus 5. Some students will say, oh, Ms. Tapia, I'm done. Let's read the directions again. This says, set each factor equal to 0 and solve. The stuff that we did with questions 1 through 17, that was reviewing a concept of how to factor, which you, again, learned in Algebra 1. What we're going to do now is factor this by the zero product property. Again, which you learned in Algebra 1, and we're going to solve. So down here, I'm going to set each binomial equal to 0, and we're going to solve. So we're going to add 6 here. X will equal 6, and then we'll subtract 5. X will equal -5. So over here to the side, how it says solution, my two solutions are -5 and 6. And you could technically put the 6 first, but I just saw -5 first, so I wrote -5. That little bracket, the squigglies, are just is one way that you can write your answers. Your homework might be a little different. It might have you put it in parentheses, but this shows each of these solutions, and it tells me that it's not a coordinate. All right, next page. For question 2. This one, again, I first need to make equal to 0. So in order to make this equal to 0, I'm going to subtract 10x on each side. When you do that, guys, be careful. The reason why is because you need to make sure that you put this 10x right in the middle of the x squared and the 8. If you don't put in the middle of the x squared and the 8, you're going to put it behind the 8 and you're going to completely forget that this is your bx term. So you need to write this in ax squared plus bx plus c form. So we're going to write this as 3x squared minus 10x minus 8 equal to 0. That should be how you write this out. Okay, I'm going to really quickly check all of these. Is there a GCF that I need to factor out? There isn't. I don't think I checked that on the last question, but you guys are lucky. There's not a GCF we had to factor out. And from here, I'm just going to factor like normal. A is going to equal 3, B is -10, and C is -8. So let me draw my little X chart. And let's try to find two numbers that will multiply to 8 times 3, which is going to give me -24. And two numbers that will add up to -10. Okay, 24. Let me write the multiples. I can do 1 and 24. I can do 2 and 12. I can do 4 and 6. Let me start with these for now. If I need to put more, then I'll try to think of more. Keep in mind, this 24 is negative, so I need to make one of these sides, one of these sets of numbers, negative. Keep in mind, I want these to add up to negative 10. Okay, so let me think. I can start off by putting the negatives on this side, but as you add and subtract, you're going to start seeing what answers should be positive and which answers should be negative. And oh, look, just my luck. I actually was trying not to put this, but it's okay. When you do 1 minus 24, this will give you negative 23. That one won't work. 2 minus 12 will give you negative 10. This one does work. I was trying to show you guys what it looked like with putting these as negatives because you won't get the answer right away. But it's okay. We'll do that for another question. And then 4 minus 6 is going to give me negative 2. Okay, those definitely don't work. So the only solutions that I can use, or the only factors I can use, are 2 and negative 12. Okay, well, with that in mind, let me go ahead and finish factoring. Since the a value is not a positive 1, we have to factor by grouping. A lot of students think just because they smile pretty that I'm going to forget about it and let you just put both binomials. No, you have to factor by grouping. So I'm going to put my work up here. We're going to make this 3x squared. Instead of putting minus 10x, I'm going to do positive 2 and negative 12. Because when you combine both of those, you'll get negative 10. So I'm going to put a plus 2x minus 12x minus 8. And we're going to set this equal to 0. This is what, in gray, this is what you need to factor by grouping. So in the first group, okay, I can't factor out a number because 3 and 2 are pretty much prime. I can't factor anything else out. So let me just factor out an x from each of those. That's going to leave in parentheses 3x plus 2. In the second group, okay, I need to factor out a number. Definitely we're going to make this a negative number, whatever I factor out. 12 and 8, I can divide both of those by 2. And I can also divide them by 4. So let's factor out a 4, negative 4. That's going to leave in parentheses. 4 times 3 will give me 12. I didn't factor out this x, so I need to copy that x in the parentheses. And then negative 4 times positive 2 will give me a negative 8 here. So negative 4 times positive 2 will give me negative 8. One thing you should automatically notice when you do this organically is that both of these binomials match. Don't just make both of these match even though the numbers don't multiply correctly. Make sure the numbers multiply correctly like I was doing, and they should both be the same. So we're going to make one of the binomials 3x plus 2, and the other binomial will turn into x minus 4. You're not done, guys. You have one last step. By the zero product property, we need to take 3x plus 2, set that equal to 0, and x minus 4, set that equal to 0. So we're going to solve. Those are my two solutions. Make sure you show the work on how you got your answer, guys. So my solution is going to be negative 2 over 3 and positive 4. You can put the positive 4 first and write it as 4 and then negative 2 over 3, but it's up to you. Okay, for question 3. Okay, remember, you should have started this off on your own. Some students will say, oh, Miss Toppy, if I try to use the X chart, it gives me some crazy stuff. Okay, well, don't use the X chart. Remember how on the first page it showed you the GCF that you could do? There's only 2 terms here. And if I look at both of these terms, I can factor out an X from each. For questions like this, that is the first step. Remember how I said I kept forgetting to check for the GCF? This is why I have you guys check for the GCF first. Because when you check for the GCF, you can see, oh, well, for this question, I don't have to do the huge X chart. I just need to factor out your X and then use the zero product property to set each binomial or each term equal to 0. This X is not a binomial. However, you need to set this equal to 0 because 80% of my students will forget to put this as their answer. X equals 0 is one of your solutions. The other solution is 2. So there's 2 answers that I want to see here. On your test and quizzes, y'all will definitely give me 2. I'm not doubting that you'll forget to put 2 down. You'll definitely do it. But the 0 is what I'm betting about 80% of y'all might forget. So we're going to put that 0 behind it and bracket it in. Make sure you actually factor out that x first, because that is pretty much factoring. That is the whole point of what we're doing. All right, last question I'm going to talk about is question number 4. With question number 4, this is a difference of squares. So let's go ahead and solve. So I can actually take the 4x squared and I can square root it. Okay, the square root of 4 is 2. The square root of x squared is x. So let me write out one of my binomials. This will be 2x, 2x. And then let me take the square root of 1. Well, the square root of 1 is just 1. Remember, guys, one binomial needs to be positive. The other binomial needs to be negative. We're not done, guys. Remember, this said to solve. So set this equal to 0 and solve. On tests and quizzes, y'all always forget when I put solve, y'all just factor it and think you're done. If you do not solve, I will not give you full credit. So we're going to take 2x plus 1, set that equal to 0, 2x minus 1, and set that equal to 0. We're doing this step in purple by the zero product property. We're going to go ahead and subtract 1 for this first binomial, the 2x plus 1. All right, I got one of my answers. And then I'll do the other one. So for the difference of squares answers, you should see two answers that are pretty much identical. However, one answer is negative and the other one, well, it doesn't have a positive symbol, but it's going to be positive. So for my answer over here, I'm going to write my solution as my little bracket as plus or minus 1/2. And if you're like, wait, Ms. Tapia, I put positive 1/2 and then I put negative 1/2. That's fine. Both of these are the same. So just pick one way you like writing it and write it that way. If you have questions, you have extra practice problems at the bottom, and you have extra practice questions on your homework as well. If you have any further questions, guys, please make sure you let me know. This concludes reviewing how to factor quadratic equations and solving.